Hello everyone. Now we're going to go over part 2 of chapter 8 for CS 110 at Laurel Ridge Community College. My name is Amit Brambhat, and let's go ahead and talk about subprograms. So the subprograms is a section of code that can be reused throughout a program. When a program encounters a call to subprogram, it pauses what it's doing, executes the subprogram, and then returns to where it left off. This structure allows us to break large programs into smaller manageable pieces that perform specific tasks. The key advantage here is modularity. We can organize code more clearly, avoid repetition, and make maintenance easier. Subprograms also help isolate logic so changes can be made locally without affecting the entire program. Parameters and arguments. What if the subprogram needs information from the part of the program that calls it? That's where parameters and arguments come in. Parameters, also called formal parameters, are listed in the subprogram definition. Arguments, called actual parameters, are the values supplied when the subprogram is called. This setup allows data to flow into a subprogram so it can operate on specific values rather than generic placeholders. Understanding this distinction is crucial for writing flexible, reusable functions. Value versus reference parameters. A value parameter receives a copy of its arguments, and changes made inside the subprogram do not affect the original value. A reference parameter, on the other hand, receives the memory address of its argument. So changes inside the subprogram directly modify the original variable. Choosing between value and reference parameters is important because it determines how data flows and whether a subprogram can alter the caller's variables. Here is an example of how subprogram looks like. The slide asks which parameter must be passed by reference. Although it doesn't provide answer explicitly, the idea is that parameter intended to return information back to the caller or modify the caller's data must be passed by reference. If a subprogram needs to update variable in the calling unit, passing by values won't work because only a copy would be changed. This concept helps students recognize when reference parameters are necessary, particularly for output or accumulator variables. The ethical issues around workplace monitoring. Now we shift to think about ethics by exploring workplace monitoring. It raises several questions. Do privacy rights extend into the workplace? What exactly is employee internet monitoring? And how might email be considered equivalent to DNA? This question encourages us to think critically about surveillance, data rights, and how much oversight employers should have. In many workplaces, monitoring is common. Employees may be tracked through email usage, web browsing, digital tools, etc. The ethical issue revolves around balancing security and productivity with personal privacy. Here, the slide represents a historical figure as computer architecture transformed modern computing. The clue states that in the 1940s, this person developed an architecture so influential that today's computers are still referenced by his last name's machines. This refers to a stored program architecture, foundational idea behind nearly all modern computers. The slide engages students in identifying, figure, and appreciating how early innovation continue to shape computing today. The photo is provided by the US Department of Energy. That's a hint that you may receive from here, and it further grounds into historical context. Here, there are several thought-provoking questions that are meant to spark curiosity. For example, how did Keeling Middle School use mobile phones to lower students' resting heart rates? Was peer-to-peer funding? Which branch of mathematics is applied in terrorist detection? And what is an EAN message? While the slide doesn't provide the answers, it encourages learners to explore how computing concepts such as data analysis, communication protocols, and mathematical modeling connect to real-world applications in education, security, and finance. Here are some more questions, such as what are lending clubs and how do they reduce borrowing costs for small businesses? How did the 2007 economic stimulus package provide feast a day for scammers? And what is the difference between hacker and a cracker? These prompts highlight how computing intersects with economic cybersecurity and online communities. Here is a chance to explore ethical, financial, and technical dimensions of digital world beyond traditional programming topics. I hope you enjoyed today's class. I hope to see you in the next lecture. Take care. Bye.